Saxon Advanced Math, Lesson 14.d, and this is coordinate conversion. Now they're jumping right into this because this is a continuation of the other parts of Lesson 14 with i's and j's. And if you need a review on i's and j's, just remember that I stands for the x value, the j stands for the y value, and all we're doing is we're just adding them as a plus or a minus instead of it with a common notation. Very similar. Now what they're asking us to do is convert negative 3i plus 2j. This would just be written, if I did this in a standard formation of notation, I would have written this as negative 3 comma 2, right? And that's what we're used to seeing. And so when I look at that, I need to convert that value, and I'm sorry, I'm not paying attention, I wrote it twice there. I'm converting that value into a polar coordinate. When I'm converting this to a polar coordinate, I have to think about what polar coordinates mean. And the book just goes into this as a review. I'm going to go a little bit more in depth. So in a Cartesian plane, you say I have my x and my y values, and so I can find any point. For instance, this one here is back 3 up 2. That point exists, but it can be described in more than one way. So when we describe a coordinate plane like this in a polar numbering system, we're no longer saying let's define this as how far left and right and how far up and down it is, keeping it on the plane. We're going to define this as, from the origin, an angle and a radius. So in other words, if I looked at it, I said, well, a radius would be a certain distance away, right? So from this point, and all of the points on that circle would be that same distance away. Then I need to define, once I say it was that certain distance away, and it would be how far that is from the center, I could define where it is by looking at from a standard position how many degrees it goes over in through all 4 coordinates or through 4 quadrants. So I'm going to say this from here to 0 to 90, and then 90 to 180, 180 to 270, 270 to 360, and I'm going to be able to define where that is, just like I could say if I wanted 2 comma negative 3, or negative 3 comma 2 is in the second quadrant. But if it was in the 4th quadrant, we could have that same triangle, if you will, in the 4th quadrant by swapping those negatives and positives, right? Because it would be a positive 3 and negative 2 would put us down here. So this is all we're doing with a coordinate is conversion, is we're looking how far is it from here over to this with the angle, and then how far from the origin is it, and that's a radius. So when we do that, I redrew the triangle larger so you could see it. Most of you are going to recognize it is a right triangle, right? Because we're defining it to be such. And because it's a right triangle, we're going to look at it and realize that I can use a Pythagorean theorem. A squared plus b squared equals c squared. So I did so. The root of a squared, so 4, b squared, there's your 9, and 4 9 is 13. My radius is the root of 13. So the distance from here to here, or on my diagram from here to here, is root 13. Now I need to be able to define the angle, and I've labeled it. There are 4 ways I can define it, and we'll get to the first 2 are very easy. I can say from here all the way over, or that's 1. 2 is going to be from here back to that point, or negative direction. So we'll start with the first positive point, and we go from here to here, and we realize, well, I don't have a way to figure this out easily, but I do have a way to figure this one out. If this is my theta, right here, my unknown angle, what trig function would deal with the opposite and the adjacent? Well, the opposite and adjacent is the tangent. So I'm going to use the tangent of 2 over 3, right, which is 0.66. And if I use the negative, it'll tell me it's a negative, but that's going to give me a 33.69 degree angle. That's this angle right here. Unfortunately, that's not the angle that I'm specifically looking for. 33.69 is this inside, and I want, from my first point, that's why I redrew it here, from here over to that line, in how many degrees of angle it would go through would be 180 degrees minus that amount, right? Or because that would be the easiest way to define how that is. Because if I went all the way to 180 and then backed up the 33.69. So 180 minus 33.69 is 146.31. And this is the way I'm going to write the polar coordinate. Root 13 with an angle of 146.31. This is my primary or my first answer, and that's the most common. Why? Because it's a positive radius, no problem, positive angle, and that we think that way. That's your first one. But there's more than one way to find that point. So we already mentioned that 2 would go from here going backwards. Well, if I went from this point all the way up to here, that would be 180, plus my 33.69 is this little piece right here, and that's going to give me negative 213.69, right? And it's negative because of the direction, and that's going to be my second angle, or my second answer. So I have radius and angle. Now, the next one is a little confusing to some people. So we're going to look at the radius as a direction. We're coming from here, we're going out. So if I went out root 13, that's a positive. But what if I went back root 13 from the origin? It would put me in the 4th quadrant. Well, if this angle right here is 33.69, then this angle right here is 33.69, but it's a negative, right? Because it's going from here down. So I can write this next one, the next answer, as, and I didn't put this in here, negative root 13 with a negative 33.69. Because I'm going all the way up, I'm going back down the negative root 13, and the direction is negative 33.69. I'm going to do the same thing to get from here all the way around for the next one, right? And that's going to be a negative root 13, right there, and I apologize I didn't have the negatives in, and that's going to be 326.31. So I'm going all the way around. I have the 3 and the 4 backwards there, but I think you get the general idea. This would be 1, 2, this is the 3rd one we did, then we did the 4th one, going all the way around 326.31 degrees. These are your 4 answers. The order doesn't make a difference. I can tell you this is the one most commonly used. That's why I circled it there for us. We use that because it is positive radius, positive angle. So I have different ways I can write it. Positive radius, positive angle, right? Positive radius, negative angle, okay? Then I have a negative radius, positive angle, and a negative radius, negative angle. So I'm going to go ahead and use all 4 of those to define exactly where that is.